Hey everyone, and welcome to this explainer. Today, we're diving deep into the fascinating and honestly, kind of mind-blowing world of food forensics. We're going to play detective and uncover the hidden truths within our modern food supply. Let's get right into the cutting-edge science keeping our food safe.
To kick things off, I want you to think about this question. How do you actually prove a gummy bear is halal? I know, it sounds a bit like the setup to a joke, but it's a very real, very massive challenge. Think about it. A simple gummy bear or a fruit jelly is made up of heavily processed ingredients like gelatin. By the time it's molded into that cute little bear shape, you literally cannot just eyeball it and know whether that gelatin came from a cow, a fish, or a pig. Tracing the origins of these ingredients requires some seriously advanced detective work. So to understand what's really at stake here, we need to know what we're testing for. For billions of consumers globally, food integrity is rooted in an Islamic dietary concept called halal and toyyiban. Now, this standard demands that food is not only halal, which means it's permissible and totally free from forbidden things like pork or unauthorized alcohol, but it also has to be toyyiban, and toyyiban means it's wholesome, safe, clean, and ethically produced. Ensuring food meets this standard is so much more than just glancing at an ingredient list. It's about verifying a really high standard of safety from the farm all the way to your table.
But here's where the plot thickens. Our global food supply chain is unbelievably complex. Ingredients for a single snack could easily be sourced from 5 different countries, processed in massive industrial facilities, and then mixed into what scientists call a complex food matrix. Because of this, traditional manual checks or relying on paper trails, they just don't cut it anymore. We can't simply rely on the honor system to stop fraud or contamination. We need advanced lab forensics to literally look inside the food and reveal its true history. Now, as we set up our high-tech forensic lab, we have to keep a major green subplot in mind. The tools we use need to align with that concept of toyyiban, meaning the testing itself should be ethical and environmentally responsible. Older, traditional testing methods were often really heavy on harsh chemicals, they destroyed the samples, and it took forever. But modern, sustainable testing, it is eco-friendly, incredibly fast, and largely non-destructive. We're talking way less chemical waste. This shift toward green analytical chemistry is completely changing the game for food authentication.
All right, let's meet the first hero in our forensic arsenal. I like to call this one the magic eye, but in the scientific community, it's known as molecular spectroscopy. Specifically, we're talking about FTIR, or Fourier Transform Infrared Spectroscopy. This is the ultimate non-destructive green tech. Instead of melting a sample down in toxic acids, FTIR just shines a specialized infrared light right onto the food. It then reads exactly how the food's molecules vibrate and interact with that light, giving us a unique, undeniable fingerprint for every single compound inside. And the physical chemistry here is just amazing. When you analyze different animal fats with this infrared light, clear differences emerge. So while beef, chicken, mutton, and pork fat might look pretty much identical to the naked eye, the magic eye sees them as completely different worlds. For example, there's a very specific carbon-hydrogen bond in pork fat, or lard, that reacts strongly at a precise frequency. The light absolutely does not lie. It hands us undeniable physical proof of what's really in the mix. To bring this out of the abstract, scientists are actively using this magic eye right now to spot hidden derivatives in everyday snacks. It's successfully identifying porcine gelatin hidden inside soft jelly candies. It can scan traditional Rambach crackers and instantly tell if they were fried in lard or made with pig skin instead of cow skin. It can even scan a standard beef meatball and detect if cheaper pork meat was illegally mixed in to cut costs. It is an incredibly powerful first line of defense. But, sometimes the magic eye needs a little backup. Enter detective number 2, the sieve. Formally, these are known as chromatographic techniques. We bring in the sieve when the clues are just impossibly tiny, invisible traces hidden inside super complicated mixtures. We're talking about minute fragments of amino acids or trace amounts of unauthorized alcohol. Light alone might actually miss these because they get buried under thousands of other compounds. So we need a way to physically sift through the food and pull the suspects out, one by one.
The way this sophisticated sieve works is basically a brilliant 3-step dance. First, you extract. Scientists use specialized eco-friendly methods to pull the target compounds out of the food matrix. Second, you separate. Using tools like high-performance liquid chromatography, they push that liquid through special columns that separate every single molecule based on its chemical properties. This perfectly isolates those sneaky heat-sensitive traces. And finally, step 3, identify. Highly sensitive detectors pinpoint exactly what the substance is, proving without a shadow of a doubt if non-halal elements are present.
This technique essentially gives us a clear police lineup of chemical suspects. Take meatballs, for instance. When scientists test meatballs adulterated with wild boar meat, they find massive spikes in specific volatile compounds like aldehydes and terpenes compared to normal beef or chicken. Wild boar leaves behind its own unique chemical biomarkers. Gas chromatography catches these exact volatile footprints, making it practically impossible for a fraudster to hide their tracks. But now we run into a brand new problem. We've got our magic eye reading millions of light vibrations, and our sieve pulling out thousands of trace molecules. This brings us to the climax of our investigation, the data dilemma. What actually happens when the biological evidence generated by all these machines is just way too massive and chaotic for a human brain to read? A single sample can generate thousands upon thousands of data points. How on earth do scientists make sense of all this chemical noise? Well, the answer is our final detective, the brain. This is multivariate data analysis, or MVDA. As researchers point out, MVDA uses advanced statistical and mathematical methods to filter through the noise, produce good data, and extract the really relevant information. In plain English, it uses heavy-duty math to find hidden patterns in the chaos. It tunes out the background noise of the food matrix and highlights the exact chemical signals that prove a food is authentic or exposes it as a fraud. When you put this digital brain to work, it does something amazing. First, it takes all that complex, raw data and sorts it into clear visual patterns, essentially clustering similar samples together so scientists can instantly see if a sample belongs in the beef group or the pork group. But it goes even further than that. It builds predictive models. That means the algorithm can analyze a brand new, unknown meatball and not just say, hey, there's pork in here, but actually calculate the exact percentage of the hidden non-halal component. It's literal mathematical precision applied to your dinner. So let's tie this whole investigation together. What we've been exploring is a powerful authentication synergy. FTIR spectroscopy acts as the eye, rapidly reading molecular fingerprints without destroying the food. Chromatography acts as the sieve, meticulously isolating the microscopic trace evidence. And multivariate data analysis acts as the brain, crunching those complex patterns to give us undeniable answers. When you combine these three methods, you get a sustainable, practically foolproof system that guarantees ethical food consumption and real consumer trust.
Which brings us to our final thought for today. We all rely on labels every single day to make choices about what we feed ourselves and our families. But behind every trustworthy label is an entire team of scientists and an arsenal of incredible technology working around the clock to ensure that what's on the box is exactly what's in the food. So, next time you check a food label in your pantry, ask yourself, what invisible forensic science is working behind the scenes to keep your food safe, authentic, and wholesome? Thank you so much for hanging out with me for this explainer. Keep learning, keep asking questions, and I will catch you in the next one.